So, when you're asked add two fractions with different denominators, you look for common denominator, but when one fraction is a multiple of the other, and not just a multiple, but a power, okay, of the other, you don't really have to do that. Okay, think about money. If I have half a dollar, how many quarters do I have?
50.
How many quarters do I have if I have half a
wait,
dollar?
no. Oh, sorry, 2.
I got 50 cents, but I got 2 quarters. So I got 2 quarters plus 1 quarter is 3 quarters. So I don't need a common denominator per se. I just have to think about how to add together two things that have something in common with the power. So 3/4, right? Mm-hmm. Okay, so now you take a look at the next question. This is right here. So I don't have to start from scratch. So now it's really 3/4 plus 1/8. But how many fourths are in an 8? 2. So that's really 6/8 plus 1/8 is. All right, so see if you can get the last 2. Trying not to bother with the whole get 4 denominators. Use your prior answer, which we now know is 7/8, and you're just adding on a 16th. Again, kind of the process is the same. What do you do, Taj? Take the 7 and take the 7 and
convert it to multiple.
Because there's 2 8s and a 16th, so I got 14 plus 1 more. It's 15. Okay. Now I'm not doing that at all this time, but you look at the top. So really, what am I doing with that 3? All I'm doing is doing what? Multiplying. So to get this one, I can't do that in my head. When my baby boy, who is now 24, was little, he did not sleep through the night. So I would literally hold him for like hours. And I did 2-digit arithmetic in my head. And whenever you're doing 2-digit arithmetic, you use expanded notation. Now, I didn't physically like hold him in one hand and put stuff on the paper, doing it in my head. So 3 times 10, Sydney, is 30. Avery, what's 3 times 5? So you can do 30 plus 15 in your head. Okay? So that's 45/16. So whenever you're multiplying by a 2-digit number, my recommendation is do not do what your 3rd grade teacher told you to do. Okay? Do not do the 3 times the 5 and carry the 1 and that. Okay? Go from left to right. Our brain works better from left to right. We read from left to right. We do math from left to right. So that was the first time you might have had a little struggle. That carrying and borrowing stuff. Yeah, I don't do that. I had a college professor, and I learned it from him. He never, ever subtracted. If he had to subtract 2 numbers, he always added up. He said, what do I add to 18 to get to 45? Well, I know 18 plus 30 is too much. So 18 plus 20 is 38 plus 7 more. Or 18 plus 20 is 27. I did. He do it fast. Okay. If you ever go to the store, cash register, nowadays the cash register does it for you. But when the cashier, anybody a cashier in here? So if somebody pays $15, how do you give them the money back? Do you count? You ever counted for them? So you count. They give you 15, it costs 12. You say 13, 14, 15. You count up so they know that the money they gave you and the money it cost, $3 and 12 go together. So most cashiers, when they're trained, that's what they do. All right. Tyler has a piece of paper and is sharing it with Elena, Claire, and Andre. He cuts it into 4 equal pieces and hands one piece to each of the other people and holds one on to himself. What fraction of the original piece of paper does each person have? Okay, so the key is to take a look at the instructions. This is not complicated, right? What do we got, Maeve? 1/4. Okay. So he takes the paper in his hand. He then does it again. Okay. So he takes that paper, cuts it into quarters, and gives it to everybody. Don't say it. Figure it out. How much do they have now? So he has the paper in his hand. They still have the paper in their hand. He takes the paper in his hand and cuts it into quarters, and each one of those persons a quarter of the paper he has right now. How much of the total paper did they have? Okay. Total. Okay. So what fraction of the original piece each person had? Give you a hint. It's not as teeny tiny as you think.
Oh, never mind.
Okay, remember, they still have a quarter in their hand. And now we're adding on how much more? A quarter of a quarter. 1/16. So they don't just have a 16th because they still have the original quarter. How many quarters in a 16th? 4. We just said 4 goes in a 16 4 times. This is 4 plus 1 is? Who said 2? Okay. All right, try the last one on your own. He does it again. So he's got this tiny little, and he's going to cut it again in the quarters and hand that out. One more time. Try it on your own. But cutting in the quarters again. Okay? So we have 5/16 plus 1/64. Hey, how many 64s go in? How many 16s go into 64?
4.
So take 5 times 4 is 20, plus 1 more is 21. Okay. Question.
Nah.
All right.
That's pretty easy.
So he keeps his remaining one fraction of the original piece. Something doesn't look right. What happens after more steps of the same process? Oh, okay. Did you just lose the Wi-Fi? This is 3, 15/16. Okay. Tyler then takes his remaining paper and does it again. What fraction of the original piece? That's not worded really well, so we're going to leave that out. Okay. All right. We have an equilateral triangle. Okay. So in this one, you have a couple options. You can take a piece of paper out, or what you could also do is just draw on here, because you're going to be drawing on here. You're going to want to make it real big, like I kind of have it. So step 0 is the equilateral triangle. Step 1 is think of taking a third of the way across each side. Okay? And then take this and pull it up and pinch it and pinch it and pinch it, and you get these. So instead of 3 sides the triangle, now I have a 6-sided star. Okay? And this is a polygon. You're used to seeing polygons that are convex. This is concave because it gets pushed in. Okay? So we're going to do this one more time. So what you're going to draw, take the little draw tool, and I would just use the draw tool. And we're not going on the corners. So think of taking like a third of the way and a third of the way, and just a little bit right here. And then another one right here. And another one right here. And another one right here. And another one. And go all the way around. It's going to take a minute. Okay? Okay? Oh my gosh, who just said that? Who said that? This is called a Coke snowflake. That's exactly what it's called. Okay? So here was one came. This was the one that was the second one. This is the one that we just created. Okay? And that is what it's going to look like in the next iteration, because then again, pull, 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 and then you can get all sorts of cool stuff. So it was first described by a mathematician, and his name was Helge von Koch in 1904, more than 100 years ago. Okay? And they're just using equilateral triangles. It's called the Koch curve, okay, where you have a line and then you just kind of pull it down, pull it down, pull it down. Every time that you see a new line, you pull out a new equilateral triangle. And you can see there's a lot of math to it and some really cool figures that you can put together because of it. Okay. So, anybody know what this type of figure is called in general? Besides snowflake, when you have every piece is really the same, only smaller. Fractal. Okay. Fractal. We talked about it a little bit when we did that Sierpinski's triangle. So this is called a Koch snowflake. So let's come back. Okay. So now we're going to make some equations eventually. Okay. But before we make the equations, what's usually the best way to start? Make a table. Okay. So let's make a table. So I'm going to stick with the drawing tool. And then S is for sides. So when my step 0, how many sides did I have? It's a triangle. How many sides does a triangle have? 3. Okay. That's a heptagon. Or septagon if you want. Okay. So my first step. So without the little blue triangles. Okay. So my first step, just start at the top and count around. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or I could cut it in half and then do half of it and because there's symmetry involved. So if I do half, how do I get the whole? Double it. Okay. So if I just started here, I got 6 on this side and just double it. So now I have 12 sides. So after just 2 steps, there it is. Drawing. Okay. I'm sure I'm doing this right. Paper tray. Tippity doo dah. So we had 1. Gave us how many? 12. 12 part? 12. What's the next one going to give me? So count. Gonna maybe just count half of it and double it. Desmond, what do you got? How many? How long does it take to count? 36? Everybody agree with 36? No.
Not really.
What do you got, Angelique?
I got 48.
Yeah, it's 48. Okay. So let's just do half of them. So 1, 2, 3. 1, 2, 3, 4. Okay. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and then double it. Okay? Hello.
Are we counting the ones we made in the previous step too?
Yes. What you're not counting is, and you can see what they did here, because I can't do it. They're kind of like erasing off this piece. So where the triangle gets pulled up, this piece right here, and this piece right here, that really doesn't exist there anymore. So you can see that when we do the snowflake here. Okay. So the bottom part of the triangle is not there. It's just the 2 sides. All right. So now that you have a table with a pattern, find the equation to represent it. I want you to do it both recursively and explicitly. Some of you need to work on creating your recursive equations, as you found out when you looked at the quizzes I graded. Okay? So do them both ways. Go up top here. Don't look at the blue. Just look at the black. Count the number. Again, I told you to highlight new triangles. So is this one new up here? No. Is this one new here? No. How about this one over here? No. Only where you see the little dotted lines. How many dotted lines do you see? So there's 3 new triangles. Okay? So come down here. Whoopsies. And I got 3. Now, all the stuff that you created, you can count. Okay, so I got 1, 2, 3, 4, 5, 6, and double is 12. You seeing a kind of recurring theme here? Okay. So without drawing it, because it's really hard, and we don't want to blow this up and take like 10 minutes to count triangles. Can we see the next one's probably going to be 48? Okay. So now you have your numbers. Now construct your equation. Okay. Actually, you know what? Did they even ask me to do that? No. Okay. So we can see that this is growing by a factor of 4, but it's a little tricky. Why? Because first it goes up by, we're adding 2 or multiplying by 3. Okay, so this one's just a little trickier, but it's not too bad. All right, scroll. Scroll. Yeah, that's right.
Would the equation for that one be the same at the top?
It will be similar, okay, but not the same, and it's going to be a little more complicated, and that's why I kind of misspoke. I don't want to get to it. Okay, so for that, I would not ask you to do something like the test. I might ask you to fill in the chart, but I won't ask you to make the equation. It's not as complicated as the Fibonacci one we did, but it's a little bit more complicated than we're ready for it currently.
Wait, so this one would be neither if you did the equation? Or?
Yeah. All right. So, suppose step 0 has a square unit of 1. So we're still looking at the same thing. Okay. After step 1, I have my area of 1, but I added some triangles. So I'm going to go back up there. And we need to figure out, in my original, if I take, draw a shape tool. I take this and kind of make some lines across, and down, across. How many, so what portion, what fraction of the original triangle, do my new triangles consist of? So I have 3 new triangles, but each one is what fraction of the original? So ignore the new ones and just count. I got 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means each one of them individually is 1/9. So I'm going to come down here. Okay. So my total area is, I still have my 1, but I'm adding on 3 triangles, each of area 1/9. So I'm actually adding on 3 9s. Now we would simplify that eventually. And I don't even want to get to the simplification part. I just want to get the setup part. Okay? So my next one, I'm making even more teeny tiny triangles. So I'm adding onto this one. So what should I do? If I want to make a new equation box, what should I do with this one? I'll have that area. And now how many new triangles am I adding on? Let's stop before we do that. What is the fraction of the new triangles? This one's going to get a little tricky. So think about it. Okay? So if when I did the first step, I made 9 new ones, how many, let me rephrase this. In the first step, I had each triangle be 1/9 of my original. In my next step, in step 2, what fraction should I have there? So take a minute, see if you can figure that out. So, my bottom is 81. What's my top? No, we just did this.
9.
How many new triangles do we got? Just did it. We just did it. Whoa! Didn't we just count the triangles? Remember? We just counted them. Okay, so I have 12. Okay. Try to find the next one. You can do this.
I couldn't figure out the 90 triangles.
3.
So each triangle is now having 9 more. So if I have 81, and each one of those 81 make 9 more.
That's 729.
Now how many triangles is there?
48.
All right. So Cindy got it. So each little triangle is going to be what portion of the original?
40 over 729.
So I have 48 new triangles. Each one is 729ths the original triangle. So it's 1/729 for each of the new tiny little triangles. It's 48. Okay. All right. So we're going to keep these relatively simple right now. So I'm not going to teach you the fancy formula for summing up things. But here's just a kind of a summary. The sum of a sequence is usually pretty easy to do when there's small numbers, and we're going to keep them small initially. Okay, so in this case, you're given $1 the first day, $2 second day. Everyone done this in like a math class, probably in elementary school. It's like on a chessboard. Say, just give me 1 penny on that first chess. How many squares on a chessboard? 64. So, and then the second day I'm working, just give me 2 pennies. And the third day I'm working, just give me 4 pennies. And the fourth, you got it. And then, by the end of the month, they'll be broke. Because if you start off with 1 penny, so just 1 little penny. Okay, that's my initial, right? But I'm doubling it, oopsies, so times 2. We'll just say it's February. We'll just take 28 days in a month. Okay? That's $2,684,345. $2,684,354.56. Yeah, nobody's gonna tell you that. Okay. Anyway, all right. So you're going to give something similar, except this next one's going to go in reverse. Okay, you're cutting down every day. You do half the amount of homework that you did the day before, time-wise. So find out the amount of homework that's going to be from Monday through Friday, and then we're done. And the rest of the period, I'm going to unlock your quiz so you can take a look at it, and you can work on any of the other assignments that we might not have turned in, including the new one for today, and then Monday, Tuesday's review. Okay, which means if you haven't turned stuff in, you need to turn it in. I'll have everything graded up till at least lesson 9 this weekend. That'll give you a second opportunity to turn stuff in before the test. Okay? We'll go over this in a minute. 40. Okay? So, let's make this big. So we're only doing this Monday through Friday, so not all 7 days. Okay? So you should know there's 5 days in a weekday, and then you get your weekend. And my clicky is not clicky. Okay, so 80 plus half of that is 40. Half of that is 20. We need 2 more. 10. I don't even know. By the time you get stuff out. All right. Do you really need this on the calculator? Okay. If you see numbers like this, I look for things that add up to be 100. So 80 plus 20 is 100. 140, 155. Boom, done. Okay. In the not too distant future, believe it or not, some of you will be able to do this yourself. But if you have time and you want to make sure, go ahead and do that in decimals. Okay. Since this is a question in English, let's answer it. It says the total time she takes is 155, and please put in the units. Okay, by columns. All right, so let me